Hi everyone. So welcome to my YouTube channel Zenith for JEE and NEET aspirants. Today I'm going to discuss a very important topic, that is center of mass. So first of all, try to understand what is the meaning of center of mass. Center of mass means the center of mass for a system of particle. It is basically at that point where we can assume the whole mass is assumed to be concentrated. Okay. So the center of mass means the center of mass for a system of particle particle is that point at which its total mass is assumed to be concentrated. Concentrated. Okay. For example, let us suppose these are the two masses, two point mass, which is equal to m, and they are separated with a certain distance. Let us suppose d. So the center of mass of these two system of particle, which is nothing but the uh, both the masses m and m, which will be lie at the center. That means at a distance of d by 2 from both the masses. Okay. Because both the masses are equal, that's why its center of mass will be at this point. So this is the point where we can assume the whole mass is assumed to be concentrated. Okay. So in the similar manner, let us suppose if these point masses are arranged in a form of triangle, that means at the corner of equilateral triangle. Okay. Then this point can be considered as a center of mass. So here again, three point masses, which is equal to m only. So the center of mass is at the geometrical center. Now, if masses are equal, then we can say that the center of mass will be at the midway of this distance. But if the masses are not equal, let us suppose the first mass is m and the second mass is 2m. Then the center of mass, we can't say it will be at the exactly at the center, but it will be at it will be close to the heavier mass. That means close to the heavier mass means it will be close to the mass 2m. Okay, that I will discuss later on. So this is the one way to define the center of mass. Center of mass is a point at which where we can assume the total mass is assumed to be concentrated. Okay. Now the second way we can also define, and this particular point we will use to derive the relation for if n number of particles are acting, how to get the center of mass. Okay. So it is the point in the space about which the net mass movement is zero. So now I have introduced one term which is mass movement, that I will discuss in the next slide. Okay. So it is the point in this particular space where the net mass movement will be zero. So try to understand what is this term mass movement means. So the mass movement so it is denoted with this particular symbol. Mass movement can be defined as a product of mass of the particle into position vector of position vector of this particular mass with respect to the with respect to with respect to the point. Point means about which you want to take the mass movement. Okay, so try to understood with this example, so it will be clear for you. So these are the coordinate system. I'm using x-axis, y-axis, and this will be the z-axis. Okay. Now, let us suppose one mass is located at this point whose coordinates are 1, 2, 3. That means x coordinate is 1, y is 2, and z is 3. The mass is nothing but the point mass, which is equal to 5 kg. So the position vector means the position of this point mass with respect to this origin. Origin is 0, 0, 0 is nothing but I am denoting with the r vector. Fine. Now if I want to take the mass movement of this 5 kg mass with respect to origin, 5 kg mass with respect to origin. So what is the definition of mass movement? Mass movement is the product of mass and the position vector of this mass with respect to that particular point, which is nothing but origin here. Okay, so this is the r vector. So here it is 5. R vector can I say in terms of I and j and k cap, that is I cap, 2j cap plus 3k cap. Okay. Now this you will get as 5i cap, 10j cap plus 15k cap. This is the mass moment of this 5 kg mass with respect to origin. But suppose if you want to calculate the mass moment of this 5 kg with respect to some other position, let us suppose that position is 4, 1, 0. That means x coordinate will be 4. So here it is 1. So let us suppose the 4 will be here. And this is 1 and z is 0. That means it is lying in the xy plane. Okay. It is lying in the xy plane. Now, I want to calculate the mass moment of this 5 kg with respect to 410. So again, according to the definition, the mass moment of this 5 kg mass with respect to 4, 1, 0 is nothing but m into r1 vector. Okay, mass is 5 kg only. Now, the main important thing is how to calculate this r1 vector. R1 means this vector. Okay, that means the position of this mass with respect to this one. So r1 vector can be say is nothing but the final position minus initial position. Okay, so final minus initial only. Now the final is I cap plus 2j cap plus 3k cap minus initial is 4, 1, 0 means 4 I cap plus j cap plus 0 k cap. So if you solve this, then you will get as minus 3 I cap plus j cap plus 3 k cap. Okay, so you have calculated the position of that particular mass with respect to 410 because I want to calculate the mass movement with respect to 410 point. So now this value is minus 3 I cap plus j cap plus 3 k cap. So which is nothing but minus 15 I cap plus 5 j cap plus 15 k cap. Okay. Now this is the mass movement about any point. So what is the definition of center of mass of system of particle? The center of mass of system of particle, according to the second point, it is the point in the space about which the net mass movement is 0. Now I am going to derive one relation how to calculate the center of mass for the system of particle. Okay, what I will do, I will take the net movement or the net mass movement will be 0. Okay, so now the next one is the center of mass of system of particle. System of particle. I hope you have seen this particular relation. Now I am going to derive. So let us suppose the center of mass of system of particle is RC. So again I will take a coordinate system in which the mass is located. This is Z axis, this is X, this is Y. Let us suppose the mass M1 will be here. Okay, M2 is here and M3 will be here. What will be their position vector? What is their position vector? Can I say the position vector is R1, the position vector of M2 is R2, and position vector of M3 is R3 vector. Okay. Now, these are the 3-point masses. I want to calculate the center of mass. Let us suppose that center of mass will be here. For these 3-point masses, the center of mass is located at this point. Whose position vector is RC vector. This is the center of mass. Fine. These are the 3-point masses. Okay, the center of mass will be at here, whose position vector is RC. So what I will do? I will take the mass moment of each and every point mass with respect to the center of mass. So what is this value? If I want to mention this, so what is this value? This is nothing but, can I say this will be R1 vector minus RC vector. Okay. Similarly, can I say this vector is nothing but R3 vector minus RC vector. Similarly, this vector is nothing but R2 vector minus RC vector. Okay. So to get the value of center of mass, what I will do? I will take the mass moment, which is nothing but this one is equal to 0. What is the mass moment of the first particle, which is nothing but M1 into R1 vector minus RC vector plus M2 into R2 vector minus RC vector plus M3 into R3 vector minus RC vector is equal to 0. Okay, if you solve this, M1 R1 vector plus M2 R2 vector plus M3 R3 vector is equal to M1 plus M2 plus M3 into RC vector. Okay, so from here you will get the RC vector, which is nothing but the center of mass of the system of particle, which is equal to M1 R1 vector plus M2 R2 vector plus M3 R3 vector. Now, this is nothing but M1 plus M2 plus M3. M1 plus M2 plus M3. Okay, so I hope you have seen this particular expression for the center of mass of system of particle. So I have discussed how that relation is framed. Okay, now, so if any number of masses are there, number of point masses are there, you just take mass and their position vector and divide with the total mass, you will get the center of mass. Okay, now this is for the center of mass in terms of position vector. Suppose if you want to write down the expression in terms of their coordinates, which is nothing but x center of mass, y center of mass, and z center of mass. So let m1 coordinate. So I have mentioned in the form of position vector r1. So this r1 can be written as x1 I cap plus y1 j cap plus z1 k cap. Similarly for r2 r3. So now I am writing in terms of coordinate x1 y1 z1. M2 will be at x2 y2 and z2, and m3 will be at x3 y3 and z3. Okay, if I want to write down the expression for x center of mass, so can I say m1 x1 plus m2 x2 plus m3 x3, because here are 3 masses. If there are 2 masses, so m3 value will be 0. Now the total mass will be m1 plus m2 plus m3. Similarly, for y center of mass, can I say m1 y1 plus m2 y2 plus m3 y3, which is divided by m1 plus m2 plus m3. Similarly, you can calculate for z center of mass, which is nothing but m1 z1 plus m2 z2 plus m3 z3 divided by m1 plus m2 plus m3. Okay. So I would suggest you just remember this particular relation, because R1, R2, R3 is nothing but the position of that particular point mass. Or if you want to write down in terms of x and y and z, that means you have to take the respective coordinate. Okay. Now, I have told you when the 2-point masses are separated with a d distance, whose mass is m and m, their center of mass will be at the center. And the second example I have told you, when these masses are different, the center of mass will be at the nearest to the heavier mass. Okay, so now I am going to discuss this particular example. You can see here, this particular example I am talking about. Let us suppose the two masses separated by d distance, by d distance. Okay, so let us suppose this is the x-axis, this will be the y-axis, and this is the origin. Okay, let me extend this axis. This is the 1-point mass, which will be at the origin m1, and the second point mass will be at m2 at a distance of d. Okay, so right now I am taking m1 and m2, both are different masses. So let us suppose their center will be of, we can say that the center of mass will be xc and yc. Okay, m1 mass whose position is 0 0, and m2 mass whose position is d comma 0, because it is lie on the x-axis. So that means y coordinate will be 0. Fine. Now you can easily calculate xc value is m1 x1 plus m2 x2, previous relation, divided by m1 plus m2. Similarly, I can also calculate their yc, which is m1 y1 plus m2 y2 divided by m1 plus m2. This will be 0 only because both the masses are on the x-axis. That means their y1 and y2 will be 0. Now, what about this xc? Xc is nothing but m1 into x1. Okay, so x1 means this is nothing but x1 is 0, y1 is 0, x2 is d, y2 is 0. That means x1 is 0 means the first term will be 0 only, plus m2 into d divided by m1 plus m2. Now you can see, if I want to write down the center of mass xc is m2 into d divided by m1 plus m2. Okay, so if both masses are equal, so now I'm just making a note point so that you will get an idea which point I was discussing. So if m1 and m2 are equal, so can I say the xc value is nothing but d by 2, which is means if m1 and m2 mass are equal, that means the center of mass will be at the center, which is nothing but d by 2. The same thing which I have mentioned in the first slide itself. You can see here. But if both masses are different, so the center of mass is closest to the heavier mass. Now you can check it here. If m2 is greater than m1, that means you know that this is m1 mass, this is m2 mass. If m2 is greater than m1, so the center of mass will be closest to the m2 mass only. Center of mass will be closest to m1 mass only. That means this distance d1 should be greater than d2. D1 should be greater than D2. So I am taking that this is the D1 because the total is D. So if I want to write down the D1, D1 is nothing but the XC, which you got already, which is nothing but M2 into D divided by M1 plus M2. Okay, and D2 can be written as, okay, So d2 is nothing but d minus d1. So d minus d1, if you do, you will get as m1d divided by m1 plus m2. Now you can see here the d1 distance. This factor will be common in both the cases. So here m2 is more, that means the d1 should be more. That's why we can say that if m1 and m2 are different mass, the center of mass will be closest to the m2 mass. That means the center of mass distance from the lighter mass will be more. You can see here, this is d1 and d1 will be more than the d2 because m2 mass is more. Okay, so from here I can make a conclusion. The d1 value should be greater than d2. That means it is closest to the heavier mass. Okay, if both are equal, it will be exactly at the center.